Assalamualaikum and a very good day class. So now we still under differentiation and integration, but we go to the application of integration with more complicated problem under area. So in this part, we will estimate the area above and below the x-axis. When calculating areas by integration, areas above x-axis are positive and areas below x-axis are negative. What does it mean here? If you have, for example, this kind of curve, and you can see this one is given by the area above x-axis. And for this one, when you compute the integration starting from the lower limit a up to the upper limit b, integrate the function f(x) respect to dx, you will got here a positive answer. But for this one, this part you can see the area for this region is below x-axis. So when integrating the function f(x) for the lower limit c up to the upper limit d respect to x, you will get the answer here less than 0, which is negative. However, we need to ignore the negative sign for this part because actually the area only represents by positive value. So how to calculate the area between a curve and the x-axis? It is actually easy for us if we can draw a graph or sketch a graph. And then we can calculate the area above and below x-axis separately. This one is very important. But because if you compute the area without doing separate part, you will got wrong answer in your calculation. And then we add the positive value of each area and we ignore negative sign of the area of for below x. Now class, we go to this example 1. The question asks us to find the total area bounded by the curve of y equal to x, x minus 1, x minus 3, and also x exists for x in between 0 and 3. So now, if you refer back to step by step, our first step, we need to sketch graph. How to sketch graph for this one? We have here function y equal to x, x minus 1, x minus 3. In this case, we need to let our y equal to 0. So we have here x, x minus 1, x minus 3 equal to 0. When we solve for this, we will have here x equal to 0, x equal to 1, and x equal to 3. Once we got this one, we can plot here our graph, which is, we know that when y equal to 0, here, this is y equal to x also equal to 0. This is 0, 0 point. And then x equal to 1, for example, it is somewhere here. We have here 1, 0 point. And then we have this one 2, this one 3. When x equal to 3, we have here 3, 0 points. So the point is given by this 0, 0, 1, 0, and also this 3, 0. However, we cannot get any idea about the pattern of the graph. So now to make it easy, we find the value, for example, here 0.5. We find the value in between 0 and 1. We compute for y. So we let here our x equal to 0.5. Our y will be equal to 0.5 times 0.5 minus 1 times 0.5 minus 3. So when we solve this one, we'll got the answer 0.625. And then in between these 2 points, let's say we choose these 2 as our intermediate value. So here when x equal to 2, y equal to 2, 2 minus 1, 2 minus 3. When we solve this one, we got negative 2. Means that here, when our value of x 0.5, our y will be somewhere, let's say here, which is 0.625. And then when our x is 2, we have here our y, which is negative 2, let's say is somewhere here. So when we can connect all these points, to get the curve of this function. You can see here, you need to find the area, the total area bounded by the curve. This is y equal to x, x minus 1, x minus 3, and then bounded by this x axis, bounded by x equal to 0, which is this is the lower limit 0, and also the upper limit 3. Here we can see the region given by this bounded curve is this one and also this part. And how to find the area? For number 2 here, we need to compute the area, which is we will integrate a function that is from, for example, a to b fx dx. This is our formula. But here, our lower limit is 0, so we integrate from 0 to 3, fx x minus 1, x minus 3 dx. But now, if you remember the previous step, you need to integrate separately based on the region. We have here this one, for example, as area 1. This one is area 2. So we need to integrate separately. Means that for area 1, the limit start from 0 up to 1. So here we have 0 to 1. We expand this function. We have here x to the power of 3 minus 4x power 2 plus 3x dx. And then plus, for this area is starting with 1 up to 3, means that start integrate from 1 up to 3. The same function. Remember class, this one is just expanding function from here. You expand this function, you got this one. So here x to the power of 3 minus 4x squared plus 3x dx. When we integrate this part, we'll got the answer here. This one is a positive side. So we'll got here x to the power of 4 divided by 4 minus 4x to the power of 3 divided by 3 plus 3x to the power of 2 divided by 2, which is from 0 to 1. And then plus, this one is negative side. Remember, you need to ignore negative sign. So we put here absolute value. So we got this one, x to the power of 4 divided by 4 minus 4x cubed divided by 3 plus 3x squared divided by 2, which is starting from 1 up to 3. And this one in terms of absolute value. When you solve this one, you will got the answer equal to 37 over 12 as the area, the total area of A1 and A2. Remember class, this one is for A1 and this one is for A2. So this is our final answer. This is what I did previously. Okay, roughly you will got this one, and you can see for x in between 0, 1 region here is located above x axis and also below x axis. So we need to find the area separately. Okay, so now we go to example 2. We need to find the area between x axis and the graph of fx equal to x squared minus 1 from x equal to 0 to x equal to 2. In this case, what we need to do first, we need to sketch graph. So to sketch graph, for our first step, we need to find when y equal to 0, we have here x power 2 minus 1 will be equal to 0. In this case, we can actually factorize this function. That is, we have here x times x, negative 1, 1. When we factorize this one, means that we got here x minus 1, x plus 1 equal to 0, which imply that we have x equal to 1 and also x equal to negative 1. In this case, we got actually our x-intercept. So now we need to find our y-intercept. Y-intercept here means that our x equal to 0. When x equal to 0, our y or fx here will be equal to 0 square minus 1, which is equal to negative 1. when we plot for this one, we have here negative 1, 0, 1, 0, and then 0. This is x0 and then negative 1. And we know this is quadratic function, means that it will form the graph like this. And the question asks us to find the area between this x-axis, okay, this one is x-axis, the curve of y equal to x squared minus 1, also our x from 0. So x0 is here. X equal to 0 means that this line, sorry, it should be on this one, okay, and then up to x equal to 2 means that somewhere here, for example, so up to this x equal to 2 means that the area is given by this region and also this region. We have two regions now. We have this one as A1 and this one as A2. How to compute this area? So that our step number 2, we need to integrate from AB, so 0 to 2, fx, x squared minus 1 dx. But now, remember, you have to do it separately because we have two regions. So class, for this one, it is equal to integration starting from 0 to 1, x squared minus 1 dx. Remember, this one is below x-axis, so we put here absolute value because we want to ignore negative sign. If not, you will got wrong answer. And then plus integration of 1 to 2 x squared minus 1 dx. Then when we solve this one, we'll got the answer here, x to the power of 3 divided by 3 minus x, which is start from 0 to 1, and then plus here x to the power of 3 minus x, which is start from 1 to 2. When we solve this one, you'll got the answer. This part is 2 over 3 plus 4 over 3, which is 6 over 3, that is equal to 2. So class, what I did here actually, this is in general the solution, okay, and this is the final answer too. And remarks here, you will do a mistake if you integrate without using separating method. Separating method means that here I separate the first area and the second area. So if you just evaluate, start from 0 to 2, you'll got here the answer 2 over 3, which is not equal with 2. So this is wrong. This is common mistake did by most of the students. So class, thank you. So class, it comes to the end of week 14 part 2A video. We will see later in week 14 part 2B video. Thank you for your attention.